So these are the hyperparameters that are available as part of the random forest. Max depth, n estimators. So these are the hyperparameters are available in this one. And now we will take a look at what exactly hyperparameter is all about. Hyperparameter tuning. So this is one of the fundamental step in the machine learning routine. So in deep learning or machine learning scenarios, the model performance depends heavily on the hyperparameter. So no matter what algorithm that you are using it, end of the day, if you don't do the hyperparameter tuning, you cannot expect the good outcome, good the accuracy. The goal of the hyperparameter exploration is to search across various hyperparameter configurations to find the configuration that results in the best performance. Okay, it is something like that. Even in our life, simple analogy is you wanted to cut cost. You want to cut down the cost. So you try all the options. You don't want to go buy your car. Okay. What is the other cheaper alternative? Likewise, the hyperparameter will use all possible combination of values, and with that, it will try to find out on its own, and it will suggest us what are the best values that needs to be used for the parameters. Okay. So hyperparameter, these are all the variables that a user can set arbitrarily before starting the training. This is the one set by the users like us. So these are basically hyperparameters are basically an adjustable parameters. As a data scientist, we can choose to train a model using these hyperparameters. We can choose our own values, range of values. You can define it here. For example, to train a deep neural network, you decide the number of hidden layers in the network. In the case of random forest, so we discussed yesterday. It builds multiple trees simultaneously. So how many trees needs to be created simultaneously? Okay, is there any way I can control it? Yes, you can use the hyperparameter. We have something called n underscore estimator. Look at n underscore estimators. And again, so now the question is, can I specify 100? Can I specify 50? Or can I specify 1,000? Or how much what value can I specify it? So that is where we do the cross validation. We have something grid search CV. So what it helps us to, so in that case, right, we define a grid. Initially, we define a grid. In the grid, we'll specify the range of values for the n estimators. N estimates is nothing but number of trees. So in that case, 50, comma, 100, comma, 200, comma, 300, comma, 400. We give four or three, four or five different values. What it does is it will try to fit our model with, it starts with fitting the model with 50 trees, and then it'll check the accuracy. And then it will start fit the random forest with 100 trees, 200 trees, and so on and so. Okay, and it keep does this one. What are the values, the range of value that you specified? It will try for each and every value, and then it compares with the different number of trees accuracy, and whichever number of trees accuracy is high, and it will say, okay, you can use 50 trees. This is more than sufficient. You don't need 500 or 1,000. Okay, it tells us the best params. We have something called best params underscore variable. With that, we can find out. So it automatically recommended by the packages. Okay, I'll show you how we can get to know all the things. Okay, and the XGBoost. Okay, we'll discuss. Sorry, not XGBoost. So this one, these are the parameters. Okay, and the next one is the parameter tuning works by running multiple trials. That's what I said. So in the case of random forest, the n estimate is number of trees. We'll specify the range of values. It runs multiple trials. First, it will check 50 trees. With 50 trees, what is the accuracy we are getting? With 100 trees, 200 trees, 300 trees, what is the accuracy that we are getting it? It automatically checks it, and then it tells, you can use 100 trees instead of 500, 50. You can use 100 trees. With that, your performance will be good. It automatically recommends. So hence the hyperparameter was by running multiple trials. Hence it's a time taking process because it has to try all possible combination of values that you defined it as part of your grid. Okay. So now we will take a look at this max depth. So what is max depth? The max depth is an hyperparameter that is available as part of your random forest. This is the one is defined as the largest path between, I just show you here. Yeah, this is the one, depth. So this is a root node. This is your child node. And here you have leaf node. Again, if you see here, this leaf, this is another uh, child node. So this one is, for him, the parent is this one. For him, the parent is this one. So the depth is 3 here. So this is, level 1 and level 2, level 3. Depth is 3. So is there any way I can control the depth rather than saying controlling the depth? Which, how much depth can I have it? Okay. So is it? Oh yeah. Is there any way I can limit up to what depth? Okay. I want every tree in my random forest to grow, but what depth it should have in it. Okay. So but we do not know. So can I try with 3? Okay. You tried with 3. The accuracy, you are getting some accuracy. So let's say your accuracy is 0.93 and still you want to improve it. So now you try with 4, 5, 6. But likewise, how many times you keep trying? It takes a lot of time, right? So this is one of the hyperparameter, tunable parameter. Okay, and so using which max depth by specifying the range of values for this one, you can get to know the optimal value for this parameter, especially when you use git search cv and all, and it can limit up to what depth you need it. So that's what this one is. And the next one is the n estimators. So we know that the random forest algorithm is nothing but the group of trees, but how many trees should we consider? That's a common question. Most of the data science or freshers, right, they'll ask this question. So we might say that more trees should be able to produce a more generalized result. Okay, so basically we want to find out the optimal. So again, we specify the optimal number of values here. Okay, so how many number of trees? Okay, that we needed. Choosing an optimal number of values for this parameter is important. Just because when I use more number of trees, it can generalize very well. If you think that way, and if you specify more number of trees, let's say, if you specify 10,000 trees or 1,000 trees, okay, it'll take a lot of time. It'll simply degrade your model performance. Okay, so hence we can we can find out the optimal value for this one. These are the tunable parameter. First of all, you should know what are the parameters that key parameters. Lot of parameters. If you go to the help, right, so you can see lot of parameters. But which all the key parameters that we need to focus? The important thing parameters. Next one is minimum sample split. This tells us the decision tree in a random forest, the minimum required number of records in any given node in order to split it. So how many number of samples should be there in each node? The default value of the minimum sample split is 2, which means if any terminal node, these are the terminal node, has more than 2 observations, right, and it's not a pure node, okay, we can split it further into sub nodes. In that case, the default is 2. Okay, if you have more than 2 observations, okay, that is not a pure node. Okay, let's say that is not a pure node, so we can split it further into sub nodes. And by increasing the value of this one, we can reduce the number of splits that happen in the decision tree, obviously, right? So when you increase the more number of samples in each node, obviously number of splits will get reduced. So therefore we can prevent the model from overfitting, increasing the value. Okay, So the next one is the maximum features, how many number of features can be used. Okay, even this one also you can find out as part of the cross validation thing, and maximum for individual tree. So when you use the parameter value, let's say 5 and 7.5 and 10, so 12.5 it goes up, but at one point in the testing data set it is going down, right? It is going down. So somewhere here you can use it, it is good. 9 or somewhere here, number of maximum features for individual tree. So by plotting this you can find out. And again, all these parameters you will get to know uh, the optimal value when you use the cross validation. Okay, the grid search CV, those kind of thing. Okay, so now the question is, what is the difference between parameter and hyperparameter? Can someone tell me what is the difference between these two? Parameter, linear regression we discussed, logistic regression also we discussed. What is the difference between parameter? What is parameter, first of all? Tell me. Parameter is nothing but the beta coefficients. Okay, the parameters are nothing but the beta coefficients. This is nothing but the model parameter, right? These are the parameters like the beta coefficients, slope, intercept. These are called parameters, right? So these parameters, are estimated automatically by the model. In the case of linear regression model, the OLS method estimates the optimal value for the slope and intercept. So in that case, the parameter, now the difference, okay, the hyper parameters are tunable parameters, whereas this we will not be able to tune it because the parameters estimated by my model. Okay, so these are the parameters, the value for the parameters are estimated by model during the training time. Whereas the hyperparameters, okay, are estimated. Okay, this is the thing. These are the adjustable parameters. So this needs to be tuned in order to obtain it. So what we can change it, that is called, what we can tune is called hyperparameters. The values estimated for the parameters during the model training, you cannot change it. You don't have any control there. Next one is, what are the various methods we can use it to find out the hyperparameters? The manual search, grid search, random search, Bayesian optimization. These are the types of, these are the methods we can use it to find out the hyperparameters. The manual search is basically a trial and error. Okay, it is simple. This is simple for the experienced data scientist, but it is not a scientific approach, which one the manual search. Okay, we specify randomly some values based on our past experience and then we give it a try. But again, this is not the recommended one. And the next one is the grid search. This is a basic method for hyperparameter tuning. So it performs an exhaustive search on the hyperparameter set, whatever you specify it. Okay, this approach is the pretty straightforward, leading to the most accurate predictions. So with this, you can find out the optimal combination. This is applicable for a lot of the hyperparameters. Okay, and the next one is the random search. Okay, this is a basic improvement on the grid search. So this method refers to this one, the random search over the hyperparameters. Basically, it does the random search. So this, as part of, using the random search, this one, it continued till the desired accuracy is reached. So this is the one often applied as the baseline, in some cases. This is, though it is more effective, compared to grid search, it is still a computationally intensive method only. We cannot say random search is less computationally intensive. So even this one also consumes a lot of thing. Okay, and the next one is the Bayesian optimization. This is the one imaged as an efficient tool for hyperparameter tuning for machine learning ML algorithms and also the complex models like deep neural networks. It gives an efficient framework for optimizing the highly expensive black box functions. Okay, and but anyhow, so what we will do is at the time of deep learning, we'll discuss about the Bayesian optimization, all the things. So we'll start with the basic grid search now, the grid search method. Okay, I just go to my churn prediction script here. I just simply go here. Look here. This is what my we can simply fit the random forest classifier. So like this, we can create an instance for the random forest classifier. You can use the fit method to train your model, and you can get. So here I did not specify any parameter, but here I just mentioned it, but I removed it here. Okay, so we have something called n underscore jobs equal to -1, which means create the trees. For example, if you specify 500, create 500 trees simultaneously. This is parallel processing, -1. If you don't specify -1, the trees will get created in sequential. You cannot leverage the feature, the underlying feature offered by random forest in this case. Make sure that you specify n jobs equal to -1. This is to parallelly build the tree, right? So especially nowadays we are working on the cloud. So we are working on cloud. Again, on the cloud, they deployed the Hadoop system and all. Okay, the distributed computing, parallel processing, everything is available on the Hadoop system on cloud. So to leverage those resources, you need to enable this one -1, okay, to parallelly build the trees. And here I did not specify any parameter. Look here, I just created a grid. You can give whatever the name that you needed, but give some meaningful name, RF grid. So here I've given the max depth 4 comma 8 comma none. Okay, and here max features. So here square root log to none and minimum sample sleeve and bootstrap. So you know what is bootstrap? Randomly sample the data with the replacement. N estimators. N estimate is 50, 100, 200, 500. Number of trees. Okay, 50 trees, 100 trees, 200, 400. So we specify for each parameter different possible combination of values. In the random state, you know very well, to reproduce the same result. And out of bag score is equal to true, and end underscore jobs equal to -1. This is for parallel processing. So we'll explain out of bag score a little later. And I just click on this. Yes, it got executed. The grid got created. And next, what I do is in the model selection, sklearn model selection, we have something grid search CV, cross validation. Here, the first argument, it takes the first argument an estimator. It can be any model, any algorithm. So in this case, we wanted to do grid search cross validation on random forest classifier. So you know very well what is cross validation. Okay, and RF grid. So here in the second argument, you need to specify the parameter. Instead of the parameter, I have already created the grid for these in a set of parameters. And underscore. See here, it is not required. Any of if it is there, it will not cause any problem. Verbose equal to true. So it will display the output here. If you enable verbose true while it is doing the grid search. Okay, and scoring ROCAUC. Use ROCAUC scoring, and then you tell me um, the optimal values for the parameters. Okay, and for these parameters. So here I had used the good thing is you can use fit even for the grids or CV, like how we use fit for the models like a random forest classifier, linear regression, logistic regression. Similarly, even for the grid search CV, we can use the fit here itself. So here I mentioned the training data set, so the independent and dependent variables. That's it. So when I do this one, what happens is fitting five folds. So the default one is five folds. It creates five folds. You remember I discussed about tenfold cross validation. Okay, if you want to specify tenfold, you can specify comma CV. So it will work. And if you want to see the syntax, you just click on it here and shift and tab. If you press it, it should give you the syntax here. 1 second, let me just. It's not coming up. Okay. So here the default one is five folds. Okay, it ran the model, it trained the model, in five folds. Okay, and the next one is or of grid CV fit. Okay, the next one is best params. When I click on it, look here, this variable best params underscore is our best friend. So it tells us of these chosen values, which value you can use it. Let's wait for some time. It's still going on. When you see star next to that, it is being processed. We need to wait for some time. Done. Oh, no, no, still it's going on. We need to wait for some more time to get the. So even the cross search, cross validation itself ran it fast. See what happened here. The grid search CV first, it takes up this value for the max depth. When the max depth is 4 and max feature is square root, something like that, and then the minimum samples per leaf 1, it take the first value and then checks the accuracy, and then it takes the second value, and then it takes the second value in this thing, and then it checks the accuracy. It builds the tree in parallel, everything. Okay, and the third one is none. It goes and checks here. For example, let's take this one. So you fit a model with 50 trees, fit a model with 100 trees, fit a model with 200 trees, fit a model with 400 trees. And then for each value, what is the accuracy? When the model builds 50 trees, what was the accuracy? When it used 100 trees, what was the accuracy? When it used 200 trees, what was the accuracy? It checks everything, and then it gives us here. Oh, still this one is going on. See, I was wondering, how come this one was. It has to, go each and everything. So it has to build 50 trees and it has to check the accuracy. And then it has to go to this one, create 100 trees, and then check the accuracy, 200. And then finally it has to give. So those days, 10 or 15 years back, we used to do it manually. We use some for loop, and in the for loop we will pass each and every value, and manually we check for 50. Again we store it in some array. So nowadays, with these classes that are available as part of these packages, it makes our life simple. It will take some time. Likewise, even the XGBoost is slightly different, the parameter tuning. Anyhow, let it do it. So this is what the hyperparameter tuning is all about. Now let's take a quick look at what is the difference between bagging and boosting. And boosting, we are yet to start. One way it is good if you can find out, learn the difference now itself. You know very well, for random forest falls under bagging. So what is bagging? Bagging is the main objective. Bagging is to reduce the variance, whereas in the case of boosting, the main objective is bias. But with the advanced algorithm like XGBoost, Light GBM, it reduces the variance as well as the bias. So in this case, each model is built independently. There is no dependency. The trees are built independently. There are no dependency. Whereas here, each model is built sequentially. So the bagging helps to decrease the model's variance, whereas model's bias, as I said, with the advanced algorithms like XGBoost and all, you can decrease both, and combining the results of multiple models to get a generalized result. In the case of bagging, we combine all the models. Okay, it's that's why we call it an ensembling model. And even boosting is also ensemble model. It builds trees on previously classified residual, thus capturing variance in data. Okay, in both the cases it uses multiple trees, whereas in the case of bagging, all the trees are uh, created simultaneously, whereas here the trees are created in sequence. But it still it takes into account of all the trees values, and then it gives the aggregated weight or something like that. So next one is the different training data sets are selected using row sampling with replacement and random selection for entire training data set. Every new subset contains the elements that are misclassified by previous models. Okay, that is the difference. This is one of the important differences between the bagging and boosting. Anyhow, this one we'll discuss it little later. And the example for bagging is random forest. The example for the boosting is AdaBoost. AdaBoost, gradient boosted mission. XGBoost, extreme gradient boosted mission. CatBoost, light GBM. These are the difference, between key differences between the bagging and boosting. Okay, so now